Okay, for this first question up here, we'll trying to figure out how many grams of lead are in this 500 liters of water. So some stuff you have to remember, and the stuff you have to remember is we're looking for mass to mass. That's what the parts per million is. It's mass of solute, so mass of lead, which is what we're looking for, divided by the mass of the solution, which in this case is of this water. And then you multiply by 1,000,000, and then that equals 10 to the 7th. Well, we need to take the 500 liters and turn that into mass of the same unit. And so since the density of water is 1, it makes the calculation kind of easy, but you got to think about it for a bit. This 500 liters, since 1 milliliter is equal to 1 gram of water, since the density is 1, we would like the liters to be in milliliters. So the milliliter number, or the liter number, goes to 500,000 milliliters. So in 500 liters, you have 500,000 milliliters of water. And since it's milliliters, I can convert, and we're talking about water, I can convert that into grams. So we've got 500,000 grams of this water. I'm not sure what the mass of the lead is, that's what I'm looking for. I multiply this by 1,000,000, and then this is going to equal 7 parts per million. So I rearrange that, and I'm going to get 500,000 times 7 divided by 1,000,000. And 500,000 times 7 divided by 10 to the 6th. And we get 3.5. So there's 3.5 grams in this 500 liters of water. Okay, which one of these is the best electrolyte? Okay, this guy here is going to break up into 3 pieces. He's going to break up, so that's the most important part, right? And he's going to break up into 3 pieces. So since he breaks up into 3 pieces, this guy gets to be number 1. Who's the worst one? The barium sulfate actually breaks up into 0 pieces, right? So that's number 4. And then what about the sodium bromide and the potassium nitrate?
2.
For both of them, right? They both break up into 2 pieces, so they're basically tied for second. It wouldn't matter which one of those 2 you put in, you get the same effect off of it. Okay. 2 reasons why chemical reactions occur. Less energy, more disorder. So if a chemical reaction can occur and the products have less energy and the products have more disorder, then a chemical reaction wants to happen all by itself. Why are they not forever? Because carbon in its crystalline state has what? What can you say about carbon in its crystalline state? Yeah, okay, so it has very little entropy. And so what nature wants is that carbon to have more entropy. So it'll turn itself into eventually carbon solid, carbon graphite and carbon solid, which has more entropy. Just wait long enough and it'll break itself down. Define entropy and give it symbols. So entropy is it's measuring chaos, or it's measuring disorder, and its symbol is an S, and its units are usually you'll see them as kilojoules per mole Kelvin. And then enthalpy is measuring heat or energy. And its symbol is an H, and it's just kilojoules per mole. Gibbs free energy. So it's how do you want to define that? What would you say about that? It's a measure of the spontaneity of a reaction based on its enthalpy and its entropy. A given reaction is endothermic and becomes more ordered. Is this reaction spontaneous? So what's endothermic mean? Thermic obviously has something to do with heat, but what about endo? Yeah, so we have an endoskeleton, a skeleton that's inside of us, and an ant has an exoskeleton. So we're saying that this reaction is bringing heat into it, and it's becoming more ordered. Is this spontaneous? No, it's completely opposite of what spontaneous could be, right? This is a fully non-spontaneous reaction. We're doing exactly the opposite of what nature wants. So we're charging a car battery, we're a tree making glucose, that kind of stuff. Needs constant energy input for that to work. Okay, so the equation for this one is really simple. So it's this delta G is equal to delta H minus T delta S. So the only way to make this at least a little complicated is to screw around with the units. The temperature needs to be in Kelvin, so that 19 needs to get turned into Kelvin degrees, or Kelvin temperature. And then look at the units for the enthalpy and the entropy. One's in kilojoules and one's in joules. It doesn't matter which one you change, but you have to change one of them. I think the easier one to change is probably the kilojoules, because the K just means 1,000. So if you take the K away, you just move the decimal place over on the 4.13 times. So, and 19, so 292K, and then I can make this 4.1K turn into 4100. All right, so I'm gonna put 4,100 joules per mole minus 290K, and I've got 12 joules per mole K. The K's cancel out. I have to cancel the K's out, otherwise I can't subtract off those two terms because they have to have the same unit when you're doing addition and subtraction. And let's see, I've got 4,100 minus 292 times 12. Okay, I put multiply in instead of minus. I get 596 joules per mole. Is this reaction spontaneous? Nope. It's a positive value. And then what about at 78 degrees? So let's go with 273, 1, 5, 351. All right, so 4,100 joules per mole minus 2K and oops, 351 here, and then 12 joules mole K. K cancels out again. And so let's just change that to 351. And I get negative 112 joules per mole. So now it's a yes. Now that the temp's been raised up, it is spontaneous. All right. Explain how you make 500 milliliter solution, hydrochloric acid. Okay, so this is kind of something that I probably did sometime in September. The hydrochloric acid bottles are sold in 2.5 liter jugs, and they come at 12.1 molar, and I'm almost never giving you guys 12 molar, so if I want to give you a quarter molar, how do I figure that out? So which equation are you going to use? Yeah, I got this concentrated solution, and all I want to do is water it down. That's it. So it's the concentration of the initial and the volume of the initial, concentration of the final, volume of the final. The concentration in initial is 12.1 molar. I don't know how much of it I need of the concentrated stuff. I do know that I only want 0.25 molar when I'm done, and I want 500 milliliters of it. Okay, so then the volume is going to be 0.25 times 500 divided by 12.1. I get 10.3 milliliters. So what you need to do is get a 500 milliliter vol flask, add, I don't know, maybe 300 milliliters H2O, add your 10.3 milliliters HCl, fill near the line, and then fill to the line, probably with a dropper. Why don't I just throw the 10.3 milliliters in the vol flask and then do the rest with the water? Does anyone remember from the safety video? When you add acid to water, it produces a lot of heat. It's a very, very exothermic reaction. So if I've got concentrated acid and let's say the first drop of water hits it, it'll actually boil it. That's how exothermic it is, because there's only one drop of water there and there's all this acid. So if you were to do that, it would splatter all over the place. It might actually, the container that I'm putting to it, it might be so violent that it might move it on the table, maybe knock it off of the table. It'll be so violent because it's sometimes when you're boiling water, you get a huge bubble comes up and it's powerful enough to like move the tea kettle or move the pot. We don't want that. So the way we handle it is we put the water in first. The acid isn't going to be able to boil, say, 300 milliliters of water all at the same time. It'll just heat the surface of the water up, but it won't be able to boil it. But if I do it the opposite way, if I add the acid to the water, that's what we want to do. If I add the water to the acid, we're in a bad situation. So put a bunch of water in first to chill the reaction out. Now I'm going to do a sodium hydrogen carbonate mixture. Okay, so first thing I should probably do is figure out what the molar mass of baking soda is. So I got 22.98977 plus 1.00795 plus a carbon 12.011 and 15.9994 times 3. Okay, 84. So I want to make a 1.25 molar solution. Okay, so I've got a 1.25 mole per liter, and I've got 0.5 liters, and I've got 84.0069 grams per mole. So the moles cancel and the liters cancel out, and I've got grams. So that's times 0.5 times 1.25. So I got 504 grams. Alrighty. So I'm going to get 500 milliliter flask, ball flask. Say half fill with water. Add my baking soda, mix, and then fill near line, and then fill 2 line with dropper. Alrighty. That's it.